Hello, hi everyone. Welcome to the Student Demand. This is your seminar. Today topic is human eye and colorful world. Human eye and colorful world. So in this human eye and colorful world, we will discuss about human eye parts and function, human eye parts and function, and power of accommodation. After that, defects, refractive defects. After that, we will discuss about colorful phenomena. Colorful phenomena. Once again, in this video, we are going to discuss about human eye parts and function. After that, power of accommodation. After that, refractive defects. After that, colorful phenomena. Okay, so be ready for it. Today, human eye and colorful world. Human eye, human eye and colorful world. Human eye and colorful world. Colorful world, human eye and colorful world. So once you close your eyes, if you close your eyes, you can't able to see anything right in front of you. You can't able to see anything in front of you. Once you close your eyes, you can't able to see anything. Once you open your eyes, you can able to see everything in front of eyes. Right? A beautiful world in front of us. We can able to see through our eyes. So human eye is the most sensible and sensitive organ in our body. Human eye is the most sensitive and sensible organ in our body. So because of the human eye, we can able to see the things. Okay. Now we will discuss about parts and function. So drawing the diagram. So you can take your and like this. So you are considering and so I'm taking the lens here, convex lens. What lens what lens it is there in the eye? Convex lens, crystalline lens, convex lens, crystalline lens. Here you can observe. So human eye, human eye, human eye. So here cornea, so frontal layer, protective layer of the eye, cornea, frontal layer, protective layer of the eye, and here until it will be here. So here we are considering like this. Okay, so until here, so iris is a dark muscular diaphragm which controls the size of the pupil. People will control and regulate the amount of light entering into the eye. Aqueous humor. Aqueous humor. Aqueous humor. Aqueous humor. Aqueous humor. Aqueous humor. Aqueous humor and vitreous humor. So this is a crystalline lens. Crystalline lens. Crystalline lens. Crystalline lens. And ciliary modules. These are ciliary modules. Ciliary modules. Ciliary modules. And next one here, vitreous humor. Aqueous humor and vitreous humor. Vitreous humor. Vitreous humor. And here I am taking the retina. Retina, and here is optic nerve. Optic nerve. Okay. So now you can observe here optic nerve. Once again, so check here. Cornea is the frontal layer, protective layer of the human eye. Most of the refraction takes place at part cornea. And coming to aqueous humor is a jelly type liquid present between cornea and eyelids. Okay, so it gives the sufficient blood and nutrition to the central cornea. And coming to iris is a dark muscular diaphragm. This is the iris. Iris is a dark muscular diaphragm which controls the size of the pupil. People will control and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. Ciliary muscles, the nervous. Okay, ciliary muscles. So we'll talk about ciliary muscles. Very, very important. So here you can observe when you want to see nearby object. Here you can observe in camera. So like a camera or mobile. So if you want to see far distance object, we'll zoom. Okay, so we'll zoom. Okay, to see that, zoom out and zoom in. Okay, to see nearby object, far by object. But you can observe here. So our eyes, without any zooming out or zooming in, we can able to see nearby object as well as far object. If you want to see far object, automatically we can see. If you want to see nearby object also, automatically we can see. How it is possible? Because of the ciliary muscles. Ciliary muscles will adjust the curvature of the eyelids. Ciliary muscles will adjust the curvature of the eyelids so that we can able to see nearby object as well as far object. So ciliary muscles will adjust the curvature of the eyelids. Ciliary muscles will adjust the curvature of the eyelids so that we can able to see the nearby object as well as far object. And one more thing, power of accommodation. Ability of the eyelids to adjust its focal length to allow the light to inside of it. That is also power of accommodation. Ciliary muscles are responsible for the power of accommodation. So power of accommodation is nothing but simple. So it allows the light to inside. Okay, so it allows the light. Which one? Lens adjusts its curvature to allow the light inside of it with the help of ciliary muscles. Ciliary muscles, as I said, zoom in, zoom out, how it will be happening in camera. Here also in our eye also, ciliary muscles will adjust the curvature of the eyelid. Ciliary muscles will adjust the curvature of the eyelid so that we can able to see near distance as well as far distance object. Okay, so coming to the eyelids. This is lens, crystalline lens or a convex lens. What are the lens? Light rays are falling on it. After that, it converge and make it falls at retina. Okay, and iris completed, aqueous humor completed. People will regulate and so people will control and regulate the amount of light entering into the eye. People will control and so people will control and regulate the amount of light entering into the eye. Okay, ciliary crystalline lens, what are the lens? Light rays falls on it, converge and make it falls at retina. Vitreous have liquid present between. So this entire portion, okay, so vitreous jelly type liquid present between eye lens and retina. Eye lens and retina. So this entire portion is filled by the vitreous humor. It provides sufficient force and pressure to maintain that shape. Okay, so to maintain that eyeball, okay, so vitreous humor plays key role. Key role. And retina is a light sensitive screen, like you can see in the cinema screen, or where the light rays project, so it falls on it. It's like a picture. Okay, we can able to see the movie. Like here, whatever the light rays are coming or entering, okay, through cornea and people. So after that, lens will converge the light rays and make it falls at retina. And retina, so light rays will meet there. It is a light sensitive screen. There are two light sensitive cells are there, rods and cones. There are two light sensitive cells are there, rods and cones. Rod sense the intensity of the light. So rod sense the intensity of the light, cone sense the color of the light. If more rods are there, we can able to see during night time also. Best example where you can observe. So owl can able to see during night time because they have more rods. And coming to the cones, it identifies the color of the light. Okay. And if more rods and cones are present at retina, that is called yellow spot. More rods and cones are present at retina, that is called yellow spot. Coming to the optic nerve, so these nerves will carry the information. These nerves will carry the information to the brain. Okay, so whenever light rays falls at retina, that two type we will get virtual, no, real and inverted image. Real and inverted image will form at retina. Real and inverted image will form at retina. Real and inverted image will form. That too 2D image. That too 2D image will form. Real and inverted and 2D image. That electrical signal will convert. Okay. So whatever the image is forming at retina, that image will be converted in the form of electrical signals through optic nerve, it reaches to the brain. So it reaches to the brain. So through optic nerve, it reaches to the brain. Brain will give the additional information. Like suppose water is filled in the water bottle. So how much it is filled? Half it is filled, 3/4 it is filled. Like that, how we can able to say, and how far it is from us. So everything, brain will add the additional information. So that we can able to see the 3D information, right? And so this is about parts and function of human eye. Once again, so we'll discuss cornea is the protective layer of the eye. Most of the refraction takes place at cornea. And aqueous humor is a jelly type liquid present between cornea and eye lens. So it provides sufficient blood and nutrition to the central cornea. And iris is a dark muscular diaphragm which controls the size of the pupil. Pupil will control and regulate the amount of light entering into the eye. And the eye lens is a crystalline lens, convex lens. Whatever the light rays falls on it, converge and make it falls at retina. And the ciliary muscles will adjust the curvature of the eye lens so that we can able to see far distance object as well as near distance object. Coming to the vitreous humor. Vitreous humor is a jelly type liquid present between eye lens and the retina. So this entire area is filled by the vitreous humor. So that too between eye lens and retina. So it gives the sufficient force and pressure to maintain that shape. And retina is a light sensitive screen where light rays will meet. Real and inverted image will form. 2D image will form. So there two types of light sensitive cells are there, rods and cones. Rods is the intensity of the light, cones is the color of the light. If more rods and cones are present at retina, that is called yellow spot. So what of the image is forming at retina, that is 2D image, that will be converted in the form of electrical signal that will reach to the brain through optic nerve. Optic nerve will send the signals to the brain. Okay, whatever the images we are getting, that is 2D image, that will be converted into electrical impulse, electrical signal that will reach to the brain. Brain will add the additional information, how far it is, how much depth it is, how much field it is. So everything it will give, that is the 3D information of the object. So that's enough. This is about human eye and their parts. Next one, so power of accommodation. I already said the ability of the eye lens to adjust its focal length to allow the light to inside of it, to allow the light to pass inside of the eye. And here there are 2 points, near point and far point. Convex lens. Convex lens is present, Rajesh. Convex lens is present in our eye. So by default, according to the defect, we will wear glasses. In glasses, it will be convex and concave. But in our eyes, it is convex lens. Okay. And coming to the next one, power of accommodation. Ability of the eye lens to adjust its focal length to allow the light to pass inside of it. That is called power of accommodation. And here generally, so just now we discussed when light rays falls on it, eye lens should converge the light rays and make it falls retina. Means what is happening on mirrors, reflection takes place. On mirrors, reflection takes place. But here we are considering lenses. Okay, so we are talking about lenses. So in lens, what will happen? Refraction takes place. If lens is not refracting the light rays properly, if the lens is not refracting the light rays properly, what happens? So there must be a defect. There must be a defect. So either light rays will meet in front of the retina or light rays will meet beyond the retina. Means other than retina. So more than other than retina point. So beyond the retina it will meet. So these two are defects only, because at retina if it is means the image will form, we can able to see, so there won't be any defect. But if the light rays will meet in front of the retina or beyond the retina, there is a defect. Based on these 2 points, so there are 3 refractive defects. One is myopia, another one is hypermetropia, another one is presbyopia. Myopia, we can't able to see near distance. We can see near distance myopia. We can't see the far distance object. Myopia means short word. So we can able to see near distance. Far point we can see. We can't see. Hypermetropia, so long word. So we can able to see long distance object. We can't able to see the near distance object. So how it will be corrected, which lens we are using, all these things we will discuss. So I created a song related to these two, okay, for remembering sake, for easily understanding. So it's very easy to sing also. I'll sing. Okay. So please do accept. If myopia, 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 near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction we are using concave lens, concave lens, concave lens, concave lens. So one more point, hypermetropia. Hypermetropia song also. Hypermetropia, 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 hypermetropia. Far a distance we can see, near distance we can see. Far a distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, Convection and so likewise, like that. So we are discussing now. So we will go to one more concept, that is refractive defects, myopia and hypermetropia. So here you can observe, I am checking here, the person is here. So this is a near point. The minimum distance up to which the person can able to see clearly without any strain or pain is called myopia. Okay. So myopia is nothing but the person can able to see near distance. He can't able to see the far distance. So far point, the maximum point up to which a person can able to see clearly, that is a far point. The minimum distance up to which a person can able to see clearly, that is near point. Near point is 25 centimeter, far point is infinity. Far point is infinity. So now you can able to see 25 centimeter, you can't able to see far distance. But somewhere between 25 to infinity you can see, right? Somewhere between 25 to infinity you can see. So that point, that is the far point of myopic person. Far point of myopic eye. Okay, so now we will draw the diagram. The same situation we'll draw in the format of diagram. So just check once. So remember this one. Remember this one. I will draw a small diagram. Okay, so that we can see here. So the person is here. Okay, so you can see 25 centimeter, you can't see infinity. Between here you can see. So that's a far point. This is a near point. Okay, so I hope it is very clear. Same situation, I will draw the diagram. Just look at the board. So I am drawing. Okay, so cornea. So I am taking the cornea like here. Okay, lens I am taking here. This is a lens, convex lens. Okay, so here also. Okay, so now you can see. So this is the near point N, and this one is the far point N. CF. So light rays are coming from far point. Those light rays will meet at retina, like here. Okay, so this is a far point and near point. Near point and far point. So if the light rays are coming from infinity, he can't able to see. Correct or not? Yes. So now you can observe here. Light rays are coming from infinity. light rays coming from infinity. Those light rays are meeting in front of the retina. Light rays are meeting in front of the retina. So here you can observe. And now you can see here. So what type of lens we are using? Concave lens. Concave lens. Concave lens. This is the concave lens. So this is N and this is F. Light rays are coming here after the diverging. Those light rays diverge. So after that again it will converge and meet at retina. So here it will meet. Here you can observe. And here also. Okay. So here those light rays are meeting at this position, because if the light rays are meeting at retina, we can able to see. Okay. So just check once. So N and here F. So if you are extending these light rays, this extended light rays will meet here. Okay. So now you can observe here. This is the far point of myopic eye. Far point of myopic eye. Myopic eye. And this one is the myopic eye. Myopic eye. And this one is the correction of myopia. Correction of myopia. Correction of myopia. Okay. So far point of myopic eye and correction of myopic eye. Okay. So correction of myopia. So very, very important. Same situation. So you have to understand the situation. Okay. How we are imagining the situation, that same situation, if that situation is there in your mind, automatically diagrams are very easy. Okay, so you will not get confused also. So simple technique, that near point we can see, for infinity we can't see. Infinity is this one, near point. Okay, so anyway we can see, right? So no problem. The problem is we need to see the infinity point. So between 25 to infinity we can see. That is the first point. That is the first point. First diagram. Second diagram is, so light rays are coming from infinity. The light rays are meeting in front of the retina. That's why we can't able to see. Here you can see, if the light rays are coming from infinity, the light rays are meeting at retina, then we can able to see by using what lens? So by using concave lens. Cataract is nothing but so on eye milky and cloudy will form. Sometimes you can observe the people. So old people, so on the eyes it will be like a cloudy, milky and white layer will form on the eye lens. Okay. So due to aging, ciliary lens, ciliary muscles weakening, automatically it form like a white, milky and cloudy. So by laser surgery only we can able to, cataract surgery. That only by laser surgery only we can remove that cataract. Okay. Now, so I hope it is very clear. Far point myopia and correction of myopia. Okay, done. So situation and diagram. That's enough. Now we'll discuss one more. So hypermetropia. Hypermetropia now we'll discuss. Hypermetropia is nothing but far distance we can see. we can't able to see near distance. For the correction of hypermetropia, we are using convex lens. Same situation as the person is here. So he can able to see the far distance. 25 centimeter he can't see. So infinity he can see. But 25 to infinity he can able to see. That is a near point of hypermetropic person. Near point of hypermetropic person. Infinity he can see. So 25 you can't see, but between 25 to infinity you can see it somewhere. So there is a near point of hypermetropic eye. Near point of hypermetropic eye. So we'll draw the same situation in the diagram. Okay, model. So that is a rainbow formation. I will discuss at the end. So in the during colorful phenomena, I will explain. So as I said, 25 centimeter. This is n. This is n dash. This is the near point of hypermetropic eye. Near point of hypermetropic eye. So now I am taking here. So those light rays will meet at infinity. Those light rays will meet at infinity. You can observe here. These light rays will meet at infinity. Not infinity, at retina. These light rays will meet at retina. So n dash, n dash is the near point of n dash is the near point of n dash is the near point of hypermetropic eye. And here I am taking. So if the light rays are coming from n, so what happens? If the light rays are coming from n, what happens? So here you can observe. Those light rays are meeting beyond the retina, like here. This point. Okay. So light rays, if the light rays are meeting at retina only, we can able to see. If the light rays are meeting beyond retina, we can't able to see, right? Okay. So here. And so next one, by using convex lens, What lens we are using? Convex lens. By using convex lens, we can correct this defect. So by using convex lens. So here n dash. Light rays are coming from here. So if you are extending those light rays will meet here, n dash. Okay. This is the near point of hypermetropic eye. Near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. Metropic eye. And here hypermetropic eye. Hypermetropic eye. And here correction of hypermetropia. Correction of hypermetropia. Okay, correction of hypermetropia. I hope it is very clear. Now check once. So near point of hypermetropic eye and correction of hypermetropic eye. Hypermetropia I can say. Done. Now, so I'll discuss about. I'll explain now only. So now we are going to the colorful phenomena. So normally, when light ray passes through the prism, it's split into 7 colors. If the light ray is passing through the prism, it's split into 7 colors. So here you can observe incident ray. So actually this is the initial direction of the incident ray. So below that one, refraction should take place. The splitting of white light into 7 colors. 7 in constant colors is known as 1, 2, 3, 4, 5, 6, and 7. So those 7 colors will form like a band on the screen. Those band is called spectrum. So splitting of white light into 7 colors. Splitting of white light into 7 colors is known as dispersion. The phenomena of splitting of white light into its constant colors, 7 colors, that is known as dispersion. Those 7 colors will form like a band on the screen. Violet, indigo, blue, green, yellow, orange, red with GR. Violet, indigo, blue, green, yellow, orange, red with GR. Okay, so the order is also like this. When light ray passes through the prism, split into 7 colors. So that phenomenon of dispersion, those 7 colors will form like a band on the screen, that is called spectrum. So if you are taking the prism, here I am taking like this. Those 7 colors, if you place the normal prism, will get 7 colors. Again, if you place the inverse position, so just besides of it, so red has higher wavelength. Okay, so I am taking like this. Then so this is the violet and red, violet and red. So here is white light, and here also On the screen also will form white light. White light. White light. So if you place, so this is a prism 1 and a prism 2. So one prism normally if you place inverted prism, so those 7 colors will form on the second prism. Again it will be combined and form as a white light. Okay. So I hope it is very clear. What is the definition of wavelength? The distance between two consecutive crusts or two consecutive troughs. So if the light ray is moving like this, okay, so the distance between two consecutive crusts or two consecutive troughs is called wavelength. Okay, done. So I hope it is very clear. Next one, water droplet we are taking. Water droplet. So that is normally so prism we can able to get 7 colors. Normally in the nature, after during rain shower, after rain shower you can see rainbow in the sky. Okay, so like you can observe. I am taking the water droplet. So this is a water droplet. Incident light rays. So after that refraction takes place. After that those light rays will come out as a rainbow form. So violet and red. So we can able to see here violet and red. Okay. So what is the phenomena involved in the formation of rainbow? What is the phenomena involved in the formation of rainbow? So the phenomena involved in the formation of rainbow is refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. So an incident light ray falls on the raindrop. Okay. So first refraction takes place. Again, so those light ray, whatever light ray incidenting on it, split into 7 colors. Yes, internal reflection of light. Okay, it's split into 7 colors. Those 7 colors will reflect internally inside of the water droplet. So it comes out as a violet, indigo, blue, green, yellow, orange, red. So what is the phenomena involved in the formation of rainbow? Dispersion is nothing but splitting of white light into 7 colors. So you can see refraction, dispersion, internal reflection. So that is the phenomena involved in the formation of rainbow. The next one, we can able to see atmospheric refraction. Normally you can see, observe. So one person is here, another person is another side of the fire. So just example, there is a fire like this. Person here. So two friends are sitting like this. Okay, so they are talking. So this person here sees through the fire. Okay, so like this, through the fire. So flame is there. Through the flame, if we observe person B, so the person image appears to be blinking, flickering, because refraction. Because of the refraction, hot air act as a rarer medium, cold air act as a denser medium. Hot air act as a rarer medium, cold air act as a denser medium. That's why when you are seeing through the flame, so it appears to be flickering. So that is normal case. Okay, so in a general case, okay, if you are taking in a huge manner like that, twinkling of stars. Actually, star position is somewhere here. So here you can observe this star position. You are standing here, okay, on the earth like that. So from here light rays are coming because of the atmosphere. So the light ray changes its direction. Actually, if it is there, it appears here. This is the apparent position. Okay, because of the atmosphere, so the position of the star appears little bit above. Because so when keep on changes, the direction also changes. Then it appears to be the star appears little bit above the actual position. Okay, so this is about atmospheric refraction, twinkling of stars due to atmospheric refraction. Yes, atmosphere density, atmosphere refraction takes place. So here one more condition. Sir, why planets are not twinkling? Why stars are twinkling? So planets are point size sources. Okay, still it won't give its own light, but still it reflects the light rays. Okay, so what happens? One way, somewhere it will be bright, somewhere it will be dark, somewhere it will be bright, somewhere it will be dark. Then so overall effect will be nullified. Overall effect will be nullified. Okay, so overall effect will be nullified. That is the reason it does not appear to twinkle. Okay, understood? I hope it is very clear. So that is about atmospheric refraction. And next one, scattering of light. The re-emission of light in different directions with a different intensity. The re-emission of light in different directions with a different intensity is called scattering of light. Okay, so blue color of the sea and blue color of the sky during evening and morning, reddish color of the sky, and remaining time it is appears blue color due to scattering of light. Related to colors, it is scattering of light. Related to positions, see the advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset also due to atmospheric refraction. Okay, atmospheric refraction. Apparent position will change. Apparent position below the origin, actual position is below the origin, it appears above the origin due to atmospheric refraction. Okay, so sunrise, advanced sunrise and delayed sunset due to atmospheric refraction. Related to colors, so blue color of the sky, reddish color of the sky, and blue color of the sea also due to scattering of light. Okay, what happens when light ray coming? Okay, so particles, what are the particles are there? This particle size is compared to the wavelength of the light. Then particle will absorb the light rays. Then it will vibrate in all directions with a different intensity. All directions with a different intensity. That is known as re-emission of light in all directions with a different intensity is called scattering of light. Okay, so next one, Tyndall effect. The path of the light becomes visible when it is passing through the colloidal solution. When light ray passes through the colloidal solution, due to colloidal solution, due to like a heterogeneous solution, mixed solution. So because of that colloidal solution, because of the colloidal particle present in the liquid, okay, because of the colloidal particles, scattering of light takes place. Then we can able to see of the light becomes visible very clearly. So you can take the red light and so you can take the water in the glass, normal transparent glass, and if you send the light ray, you can able to see the color of the light very clearly. So within that glass water. Okay, so that is about Tyndall effect. Okay, so even in the morning and if you open the windows, sun rays are coming, dust particles are flying. So that is also Tyndall effect only in the in the forest. Okay, so narrow beam of light falls, then in that narrow beam we can able to observe the dust particles of flying. And one more thing, during rainy time you can see near the bulb, during rainy time street bulb or in our normal bulb also the particles, the moisture particles are flying. Okay, near to the bulb we can able to see. We near to the bulb only we can able to observe. Okay, so I hope it is very clear. So thank you so much for joining and attending, listening my class and giving an opportunity to take the class. So I hope it is very clear. If you have any doubts, you can ask me. And also notes for grade 10 physics, CBSE, like light reflection, diffraction, human and colourful world, electricity and magnetic effects of electric current. That notes is available in the Telegram channel. I already given the link. So you can check in the description. You can check in the below the video. Okay. So you can go and check the notes. If you have any doubts still, you can send a message. And if you need any classes regarding physics, grade 11, grade 12 and 10th class, you can go through this number 98498-12804. So you can send a message to me through WhatsApp. So thank you so much for joining and attending and listening. If you like the video, if you like the channel, if you like my explanation, do like. Yes, so once ping me to this number 98498-12804. Thank you so much. We'll see you in the next class.